Hey guys, Lindsay here, and today we're going to take a look at solving radicals, which is a value under either a square root sign or a cubed root sign, not using your calculator. So the method that we're going to use is called prime factorization. So let's take a look at that. We've got a question up here, 225, the square root of 225. There's a 2 up there indicating that that's square root, and a lot of the times we actually don't see that 2. That 2 isn't written. It's implied, but that's what that means. So that means what number times itself twice would give us 225. And if you've got your calculator in front of you, I know you can type that in and get the answer really quickly. But let's talk about what we would do if we didn't have a calculator. How would we solve that? So we're going to do that using prime factorization. So let's take a minute and write 225. And basically, prime factorization is breaking this down into its prime factors. So we want numbers multiplied together to get 225, and all of them need to be prime numbers, numbers that only have a factor of themselves and 1. But it's tough to look at that number and right away think of its prime factors. So the way that we're going to do that is I'm going to look at that number and I'm just going to think of any way that I can multiply 2 numbers together to get 225. If you think of 2 different numbers than I do, it doesn't mean that you're wrong, because in the end, we're going to end up in the same spot. I'm going to look at that and I'm going to say, okay, I see a 25 there. So I'm going to quickly in my head calculate that 25 times 9 would give me 225. If you chose 5 times whatever value that is to get 225, you're not wrong. This is the way I'm going to do it. Now 25 and 9 both aren't prime factors, so we're going to keep breaking them down until we get to prime numbers. Now I'm going to take a look at 25, and I'm going to say that 5 times 5, we'll put a times in there, would give me 25, and 5s are both prime numbers, so I'm going to give them a quick circle here. Great. Let's do the same thing for 9. Let's break it down into 2 numbers that multiply to 9. Any 2 numbers will do. But other than 1 and 9, the only 2 I can think of are 3 times 3, which would give us 9. And how nice that kind of worked out. These are both prime numbers as well. So what I'm going to do is I am going to go back to this original question. I'm going to take the square root of 225, and I'm going to rewrite it as these prime numbers multiplied together. 5 times 5 times 3 times 3. And remember, that's a square root out there. So the way that we're going to simplify that is anytime that we see a pair, so in this case we've got 2 5s, it's a pair. I can write 2 5s, I can write that 5 just once outside of the square root sign, and I can do the same thing with this pair of 3s. 2 3s inside means just 1 3 outside of the square root sign. And now 5 times 3 is 15, and we've done it. The square root of 225 is 15. Let's make some room and let's take a look at another example. Okay, so let's take a look at another example. I've written up here now the square root of 360. Our last example had a perfect square root, and that was so nice that it worked out that way, but it doesn't always work out that way. So let's take a look at one that maybe isn't so perfect. 360. So I'm going to take that number, and I'm going to think, again, only of 2 numbers that multiply to 360. And for me, the easiest way to do this, as soon as I see a 0 there, I know that 10 times 36 is going to get me 360. So it's kind of a nice way to start. Now let's break these down into their prime factorization. We'll start with 36. 36, for me, the easiest way to think of 2 numbers that multiply to 36 is 6 times 6. Those aren't prime numbers. We actually have to factor those one level further. If we do that, I know that 2 times 3 would give me 6, and this 6 breaks down the same way. 2 times 3. And both 2 and 3 are prime numbers, so those have been broken down as far as we can. Let's take a look at 10. 2 numbers that multiply give us 10. I can think of 2 and 5. And again, both of those numbers are prime numbers. Now, if you thought of a different way to multiply to 360, that's okay, because in the end, our prime factorization, our prime factors are going to be the same. So it's kind of a nice thing about this question. So let's finish this off. I've got the square root of 360. I'm going to rewrite that as the square root of all of these prime factors together. And I'm actually going to pair them. So I'm going to do 2 times 2 times 3 times 3. So I'll put our pairs together. And then we've got this 2 and this 5. Can't forget those guys. Now 2 times 2 times 3 times 3 times 2 times 5 would give us 360. And remember, because there's a 2 out here, I can move pairs to the outside. I see a pair of 2s there. There is another 2, but he doesn't have a pair. I see a pair of 2s there, and I see a pair of 3s there. So I am going to write 1, 2 outside of the radical sign, outside of the square root sign. And I'm going to write 1, 3 outside. And then I have these 2 guys left over. That 2 and that 5, they don't have pairs. So they're actually going to stay under the square root sign. 2 times 5 under the square root sign. And then we're just going to finish this off. 2 times 3, sorry, I'm getting to the bottom of your screen here. 2 times 3 is 6, and 2 times 5 is 10. And we're going to leave that 10 under a square root sign because it didn't have a pair to come outside. So the square root of 360 simplified is 6 square root 10. Let's take a look at one more example, and this time maybe we'll take a look at a cubed root example. All right, guys, one last example. We're going to this time find the cubed root of 6,000. Again, if you have a calculator with you, you could probably type that in your calculator and get the answer. But if we didn't have a calculator, we could use prime factorization to do it. It's going to change a little because there's a 3 up there instead of a 2, but we'll talk about that in a minute. Let's start by just finding the prime factors of 6,000. So I'll write that up here. And the nice thing about having a value with zeros after is we can break it down by tens. This, to get 6,000, 6 times 1,000 would do it. And then we can break this down further. We're just going to do 2 numbers at a time. So we're going to break 1,000 down. Well, 100 times 10 would give us 1,000. And then let's break that 100 down into 10 times 10. Made those numbers a little bit smaller. Now 10 isn't a prime number, but we can break it down in one step into prime numbers. 10 would be 2 times 5. So we'll circle those 2 guys so we know they're prime numbers. Those 2 10s are going to break down the same way. This 10 would be 2 times 5. Circle our prime factors. And this 10, although I didn't give myself very much room, would also be 2 times 5. Back up to this 6, we haven't broken him down yet, but it's a nice small number. So in one quick step, the only way to multiply to 6 other than 1 times 6 would be 2 times 3. And both of those are prime numbers. So it looked like a really big, scary number, but pretty quickly we were able to break it down into its prime factors. 2, 3, 2, 5, 2, 5, 2, 5. Lots of them. So let's finish this over here, and we'll talk about the difference now that we have a cubed up there. So I've got the cubed root of 6,000, and maybe you can already guess what the difference here is going to be. But I'm going to write these down, and I'm going to write all of the values together. So it looks like I've got 1, 2, 3, 4 2s. So let's put the 2s together. 1, 2, 3. I've got 4 2s. I have got 1, 2, 3 5s. And a 3. So we'll put that guy at the end because he just doesn't have any partners. Now here's the difference. This question, because it's a cubed root, I can only put numbers outside of that radical sign if I've got 3 rather than partners. I've now got to have 3 to put them on the outside. So there's 3 2s. And I also see 3 5s there. I'm left with a 2 and a 3 that isn't part of a triplet, but that's okay. So on the outside of this, Those 3 2s represent 1 2 on the outside, and those 3 5s represent 1 5 on the outside. And under the cubed root sign, I still have a 2 and a 3. So let's finish that off for you. 2 times 5 is 10. And under the cubed root sign, we have 2 times 3, which is 6. So the cubed root of 6,000 is 10 cube root 6. So hopefully that helps you understand how to deal with a square root or a cubed root. You could do a 4th or a 5th root if you chose to, not using your calculator.